Hi, I'm Selva Prabhakaran. In this one, let's understand the concept behind standard errors. Often, people tend to confuse the word standard error against standard deviations. Let's clarify that confusion also so that you are very clear. As always, let's understand with an example. Say you have a large coconut harvest. You have the coconut trees spread across the state. You don't even know the exact number of coconut trees. Alright. Now you are interested in finding out the average yield per tree. We are talking about the average right now, right? We have not yet entered standard errors. So we are not able to actually go and measure the yield of every single tree. So what we do? We take samples. So here we take two samples. This is sample 1 where we have the measurements for 5 different trees. These are the measurements. Likewise, we have another sample. We call it as sample 2. Here also we have 5 different measurements. 5 different measurements. You can see the mean for first sample and the second sample is the same number, same value. But the spread of the values in sample 1 is much wider, it's widely spread compared to the values in sample 2. This is what standard deviation refers to. Now let's understand standard errors. Now let's say you have 3 different samples, sample 1, 2, 3 different samples, and you have the measurements here. These dots are the measurements of the average yield for 5 different trees basically. You have these values. The mean of the first sample is over here. The mean of the second sample is here, and the third sample is here. The mean is not exactly the same. They are slightly different because if you take measurements from sample to sample, the mean can slightly change or widely change also. It is possible. Now, the mean of the first one is 240, second one is 251, third one is 235. If you take the standard deviation of these 3 means, that is 240, 251 and 235, the standard deviation of these 3 means represents the standard error. So simply put, standard error is the standard deviation of the means from different samples, especially when you don't know how many items are there in the entire population. Also note, the smaller the standard error values, the more confidence we have about the estimate of the mean. Because we don't know the average, we don't know the yield of every single coconut tree out there. We can only estimate the mean from the samples. Now imagine this. All these 3 values are exactly the same. Let's say all these 3 values was 240 itself. Right? This was 240. This is also 240. If you compute the standard deviation of all these 3 values, it's going to be 0. Right? So if all the samples are giving you the exact same mean, you have a lot more confidence about the mean of the entire population. Now, having said that, standard error is not limited to the mean. You can also compute the standard error for the median as well, or any other statistic for that matter. For example, the standard error of a median is the standard deviation of the medians of the various different samples. But whenever someone refers to the standard error, it simply refers to the standard error of the mean by default. Why? Because standard error formula is only applicable for the standard error of the mean. So this is the formula for standard error of the mean. If you have a sample, that sample has n items, all right, and you know the standard deviation of the sample, the standard error of the mean can be computed as sigma by root of n. You can use this formula if you happen to have just one sample. If you have just one sample, simply apply this formula to compute the standard error. If you have multiple samples, then we compute the standard deviation of the means of those samples to compute the standard error. So these are the 2 ways you can use to compute the standard error. Now with this clarity, let's test your understanding. You are studying the average weight of fish in a lake. You catch a random sample of 50 fishes that measure an average weight of 2 kgs, and have a standard deviation of 0.5 kg. Calculate the standard error of the mean weight for this sample. Please pause the video and try it out. If you are able to solve this correctly, then you are clear with standard errors. The answers for this particular problem is present below the video.